We will take a look now at our last form of graphical display, and that's referred to as a stem and leaf display. Now in reality, the need for a stem and leaf display is becoming less and less and less because of technology. There was a time where the only way we could make a histogram, or only realistic way, or the easiest way I should probably say, was to first do a stem and leaf, and then from the stem and leaf go to the histogram, or a frequency distribution table. They would accomplish the same sort of a thing. Now, there still are some uses for stem and leaf display, and I'm going to create a stem and leaf display on this exam data, and I'll show you one way that I do use it. And you should be very familiar with it because you could easily run across one of these displays in a journal article of some type, and you'd want to know what they mean. So we will use the same data that we've been working with, this class data. And here's the basic idea. I'm going to draw a vertical line. And I notice that my smallest data value is in the 30s. So on the left is my stem. And my stem now has powers of 10. So this 3 is actually represents 30. This is 40, 50, 60, 70, 80, 90. If I had 100, I'd put a 10 here. And on the right-hand side are what's referred to as the leaves, and that will actually contain simply the ones place in our data. Now, when you look at the data, you will see the first value is a 92, so I'll put a 2 right here. This represents 92. The next value is an 83. The next value is a 31. Then a 56. Followed by an 87. Now it's important that I try to keep these columns lined up. See, after the 87 there's a 71, then a 62, and a 74, then an 86, and a 77, I see a 73, and so forth. So when you look at this data, the 7 and 1 means there's a 71 in my data set. The 7 and 7 means there's a 77 in my data set. Now what I just did is I paused this and then completed it real quick rather than having you sit there and watch me write in every single number, because I think you get the idea by now. Now when we look at this, if you turn your head sideways, this is really a histogram. Kind of a poor man's histogram sort of a thing. And this histogram very closely matches the histogram we did right here. It's just turned sideways. Now very commonly, and actually in reality all the time, once we do a stem and leaf like this, we always make it an ordered stem and leaf. Now what that means is, I'll do it with the 70s here. What that means is we'll take out all those numbers and I'll replace them with the same values but in proper order. So when I take those numbers and I put them in their actual proper order, what I get is 0, 1, 2, 3, 4, 4, 5, 7, 7, 9. This is now ordered, and you would do this with each one of these rows. Now the reason you order it is because now, as an example, I can look at this and I can see right away that there was one student that was very, very close to jumping into the B. And actually two of them were, well, three, if I count these 277s, were really very close to a B. And down here I can see there are actually 4 that were very close to dropping down into the D's. They just barely made the C range. So see, there's more information here than simply looking at a histogram, which tells me how many were in the C range. It doesn't tell me anything about their placement in the C range. I do not have that information. With a stem and leaf, I do. I can see the distribution within each level, which can be important. Now there is a program on the TI-8384 that is available for download that would do this. TC Stats at the time I did this video did not have this capability, and I'm not sure that we're going to add it to it. Now, one thing about stem and leaf displays, it works very, very well if we have data like this. If this data was like 92.3, 83.71, it becomes very messy data. And the stem leaf does not work well. One of the ways you can handle that is you could round this. You could make that an 84. You can make this a 92. So if you did rounding and then did a stem and leaf on the rounding, then that will work well. If the data, on the other hand, looked more like, say, 9,241, 8,317, well, now we do this a similar sort of thing where these stems would now be thousands, and again we would round. So I'd round this to be 92,000. That's what that would be. This would be 83,000, and then because the stems are thousands, again we're back to 92 and 83. So the stem and leaf would look the same. But what's happening is you're losing all this information that's contained there. But nonetheless, it is a quick and dirty, rough graph. For me personally, if I go beyond like these tens places, I tend to not use a stem and leaf. I just do a frequency distribution table if I need to take a look at the distribution or the frequencies and percentages within each category or class, and then do a histogram. For exam scores, personally I find stem and leaves to be very useful because of this additional information that is readily available.